Okay, today's lesson is lesson number 54. We're multiplying monomials with polynomials. Mono just means one, so these are polynomials with one term, and poly means many, so there's many terms there. Okay, just for a review, we want to go over what our exponent rules say. So when I multiply 2x times x, I can think about this as 2, and then I have x times x. Just like when I have 5 times 5, how that's the same thing as 5 squared. X times x is the same as x squared, so this is just 2x squared. For the next one, it's the same idea. I can write 2 times x, and then I have 4 more, so 1, 2, 3, 4. And I can see I have 1, 2, 3, 4, 5, 6 total, so I get 2x to the 6th. Okay, the kind of shortcut method would be to use our exponent rule, which says that I add the exponents. And this, I'm just noticing, this is actually wrong. This shouldn't have an addition sign in the middle. It should be parentheses. So when I'm multiplying, like bases, I add the exponent. So here, I would do the same thing. I get 3x squared times 4x cubed would give me 12, multiplying the 3 and the 4, and then x to the 5th, right, adding the 2 and the 3. Okay? Now, remember back in younger grades, right, you would find the area of a rectangle by multiplying the length times the width, right? So we're going to kind of use that idea today with our multiplication. So 5 times 11, we can think of this like 5 rows times 11 columns, right? And I could count all the little boxes, or I could skip and just say this is 5 times 11, so the area is 55. Okay, I could also think of this, instead of 11, I could think of this side as 10 plus 1, okay? Maybe I'm too lazy to multiply by 11, or I don't remember those multiples, so I can break it up this way. And I can look at this big rectangle as a 5 by 10 rectangle, and then a 5 by 1 rectangle. Okay, so the 5 times 10 would give me 50 here, and then 5 times 1 would give me 5 for the small rectangle, and then I would just add them together to get 55, which is my answer if I just do 5 times 11 too. So this is just to show you that I can break up my area, and if I add it back together, I'll end up with the same thing. Okay? So these are the steps. If you were not in class today, please write those down in your notes. Okay, so for this first example, what we're going to do is start with a generic rectangle. Then I'll write 3x as the width of the rectangle, and then write x plus 7 as the length. Okay? And just like how I broke up the area of the 5 by 11 rectangle, I'm going to break this one up as well. And following my steps, I break up the rectangle where there is addition or subtraction. Okay? So now I'll multiply each piece to find the area. So 3x times x will give me 3x squared. Then 3x times 7 will give me 21x. And that's going to be positive. So my answer then would be 3x squared plus 21x. And from yesterday's lesson, we know that we can't combine those anymore. So that's our final answer. Okay, for the next one, it's the same thing. I'm going to make a big rectangle. I'll set the width as the first polynomial, which is negative 5x, and the length as the second polynomial, which is 3x squared minus x plus 7. X plus 7. Sorry, I'm going to write it over there. So when I break this rectangle up, I'm going to split it where there's addition and subtraction, but I want to make sure that I keep those signs with the number or variable next to it, okay? So I'm going to split right before the subtraction sign and right before the addition sign. Then I'll look at this first rectangle, and I would find the area of this by multiplying the width times the length. So I have negative 5x times 3x squared, which would give me negative 15x cubed. Then I go to the next piece of area, and I have negative 5x times a negative x gives me positive 5x squared. And the final box, I'm multiplying negative 5x times 7, and that would give me negative 35x. Again, I can't combine the terms anymore, so my final answer would be negative 15x cubed plus 5x squared minus 35x. Okay, I'm going to skip this next one. It's just like the others, but this one's a little more complicated. Same idea, but since there's a few more terms, I'll go through this one. So again, I make my width the first polynomial, which is going to be 5x cubed. Then my length, I use the second polynomial, so this would be 3x squared plus 2x minus 5. I break up my rectangle right before the addition, right before the subtraction, and then I solve for the area of each piece by multiplying the width times the length. So 5x cubed times 3x squared gives me a 15x to the 5th. 5x cubed times 2x gives me a positive 10x to the 4th. And in the final piece, the area, I would multiply the width times the length and get negative 25x cubed. Okay, so my final answer is 15x to the 5th plus 10x to the 4th minus 25x cubed. Okay, these two would be for you to do on your own, but I will walk through this one with you just to review with the negatives one more time. So I write my width, negative 3x cubed, and then negative 2x squared minus x goes as the length. Splitting up the box before the subtraction, in the first piece I get negative 3x cubed times negative 2x squared, which is a positive 6x to the 5th. This second area, I would take the width times the length, which, that's to the 5th. So I would have negative 3x cubed times negative x is a positive 3x to the 4th. Again, these are both positive because I have the negative times the negative here makes a positive, and then the negative times the negative here makes this positive. So my final answer would just be 6x to the 5th plus 3x to the 4th. Okay, and that's it for today's lesson. Thank you.